In several videos of this channel, I've shown how airplanes work, but I have never talked about the control surfaces. Something extremely important to understand how airplanes can direct their flight. Get ready to learn a little bit more about airplanes. Take only 4 seconds to subscribe to this channel and enable notifications. Okay, let's start now. The control surfaces comprise all the aerodynamic parts of an airplane that are used to steer the aircraft during the flight. They are divided into primary and secondary control surfaces. There are different types of control surfaces and mechanisms to maintain control of an aircraft in flight efficiently. The efficiency range of an aircraft changes depending on its speed. The primary control surfaces are responsible for directing the aircraft. These are the elevator, to rise and lower the aircraft, moving the plane in its transverse axis. The rudder, to control the yaw, moving the plane in its vertical or yaw axis. And the ailerons, to control the roll or tilting the plane from one side to the other, moving the aircraft in its longitudinal axis. In case it is not clear to you, we'll review the axis of the airplane with this three-dimensional model. This is the transverse axis, the longitudinal axis, and the vertical axis. And the primary control surfaces are the elevator, the rudder, and the ailerons. Note that these axes converge at a specific point, and this is the point of the aircraft we call the center of gravity. It is the point where the aircraft is in balance. There is also the aerodynamic center point, but we can talk about that in another video. Then we have the secondary control surfaces responsible for modifying the lift that the wings generate or simply modifying the aerodynamics of the aircraft in other less conventional ways, by either reducing or increasing lift as well as the aerodynamic drag. Among them, the flaps. These are similar to the ailerons, but they are closer to the fuselage and they have the task of generating more lift and reduce the speed at the same time. Depending on how much is the angle of inclination of the flaps, they can slow down the airplane even more or simply generate a little more lift during takeoff. There are other more specialized surfaces, such as lats and Kruger flaps. These are used especially in large commercial airplanes and fighter jets. This is an extension in the leading edge that increases the curvature and wing area, increasing its lift at low speeds. The slats are usually deployed together with the flaps. The slats are not normally used in small commercial airplanes nor radio control airplanes, but of course it is possible to use them, only that it's not usually necessary. Finally, there are the spoilers and air brakes. These are used in commercial airplanes as well, and also in gliders to reduce the lift on the wings and slow down the aircraft at the same time. These are used in the landing process or after landing. Fighter jets can use similar devices, which can also be called air brake. To control the flight of an aircraft, the control surfaces have to generate controlled imbalances in the aerodynamic forces acting on an airplane. That way, we tilt the aircraft in its different axes to achieve the desired maneuver. Helicopters use their blades as the same control surfaces, as their angle of attack can be modified depending on their position in the path of their rotation, individually. That way they have the ultimate control. Depending on the functions played by the control surfaces in an aircraft, they are called different names. For example, in a flying wing there is no tail, and it only has 2 control surfaces. They work as ailerons but also as elevator. The functions are mixed in the same control surfaces, and in that case they are not longer called ailerons, but elevons. The same goes to ailerons that also performs the function of flaps. In that case, they are called flaperons. And there are also spoilerons, ailerons that also serve the function of spoilers. Trim pads are also found in full-size airplanes. These are also part of the control surfaces, and their task is to neutralize the position of the control surface, depending on several factors of the airplane, like its balance and if it's taking off or landing. Since the aerodynamic effects changes during takeoff and also the balance is affected by the amount of fuel or weight shifting inside the airplane. Trim tabs or trimming in general helps neutralizing the control surfaces to its new neutral point so the pilot doesn't have to be correcting the airplane constantly. Now let's talk about how you control the control surfaces or the airplane in general. Normally you will find a control stick or a yoke similar to a steering wheel. These are going to control the primary control surfaces. The control system could be as simple as using wires to pull all the control surfaces, or more complex using electronic controlled motors or hydraulic systems. To maneuver the aircraft using a control stick, you pull the stick to raise the nose and go up, push it or move it forward to go down, and move it left or right to roll the aircraft respectively using the ailerons. To use the rudder, we use the pedals, also left and right. To control the secondary control surfaces, depending on the aircraft, you can use levers, buttons, switches, and others, because that's different in every kind of aircraft. The airplanes that use yokes, as the Cessnas, work under the same principle. You push the yoke to go down, pull it to go up, and turn it left and right to roll the aircraft. That should cover all you need to know about the control surfaces. In future videos, I could explain what adverse yaw is, and the different forces affecting the aircraft during takeoff. If you'd love to see those videos, let me know in the comments below and subscribe so you don't miss it. For now, I hope you enjoyed and learned a lot in this video, and I'll see you in the next video.